So there's going to be an x and an x right here. And so when you FOIL, the first thing that you're going to do, this x times x will make what? Ellen? So your very first thing is going to be an x squared. Maddie. Lars, go ahead and close your computer. Now, the way I've taught you guys FOIL and I've taught you smiley face. For now, I'm going to do smiley face, and you'll see why in just a second. The smile and the nose, those two multiplications, this x times -5, are going to create two inside terms. So x times -5, you have -5x, and then 3 times x plus 3x. Those two middle terms are important, and once we get back to the fill in the blank section, you'll be able to see why. And then the last eyebrow of our unibrow smiley face is 3 times -5, which is -15. All right, you guys have done this before. You know foiling, I hope. If you don't, stare at this for a second. Remember. As we go forward through our foiling, these numbers, the -5, the 3, and when you combine these into -2x, those numbers are made up by, in some combination, Hannah, in some combination, multiplying, adding, or subtracting the 3 and the -5. This middle number, the -2x, we got -2 from adding -5 and 3. And then this last number, how did we get a -15? Lexi? By multiplying the 3 and the -5. And so, this FOIL problem, which you can figure out all of the coefficients in here, which is your -2 and -15. You can figure out your coefficients by looking at these two numbers and figuring out whether to add or whether to multiply. Quick, do these definitions. So quadratic trinomial, that's the term that the book is going to use to describe this. That means there's 3 terms, which is trinomial, and then the highest power is the second power. So for your definition, write 3 terms, and then you can write second degree. And then, so for the definition of quadratic trinomial, you can write 3 terms, second degree. Make sense? And so, any of you remember what a binomial is? Just a two-term statement. Here's a binomial. Here's a binomial. So for the definition of binomial, you can just write 2 terms.
Isn't it like 2 terms connected by multiplication, division, addition, and subtraction? Okay.
Yeah, so in an earlier definition I added along with that 2 terms connected by addition, subtraction. The reason why I give you that definition isn't because it's going to help you solve the example problems. It's just because it sort of bridges what we've been learning and what we're doing now. Same.
Are all quadratic trinomials, do they all have 2 degrees?
So all quadratic trinomials are quadratic means second degree. Mm-hmm. All right. Ben?
So the degree is how many variables, right?
The degree is how many variables in the highest variable term. So here we have no variables. Here we have 1. Here we have 2. This is the highest variable term, so 2 variables means second degree. All right, and now we're back to the blanks. To factor a quadratic trinomial, find 2 numbers that add to the middle coefficient and multiply to the last coefficient. So here's what I'm going to do for that. We're going to erase our work that we did over here. Okay. In all the problems on your homework, you're going to be working backwards. Before you FOILed and you got this, now you're going to take this and figure out what this was. The way you do that, and you may remember what I had written here, the way you do that is you say, what 2 numbers multiply to the last coefficient and add to the middle coefficient. And so we need to figure out what those 2 numbers are. And it's kind of a game of guess and check, where you figure out all the combination of numbers that could multiply to negative 15. And so, could you guys throw out some numbers for me? What multiplies to negative 15? 2 numbers. Carson?
5 and 15. Or 5 and 3, sorry.
5 and I'm going to say negative 3 right now, because we're doing negative 15. Any others?
Negative.
Maddie?
1 and 15.
1 times negative 15 will give you negative 15. Ben?
Negative 5 times 3.
Yeah. Negative 5 times 3. Any others?
That's a greater than sign. Or a less than sign. Negative 5 or negative 1 and 15.
Negative 1 times 15. Are there any others?
No.
Now we look at these combinations and we take the numbers and we say, what ones add to negative 2? 5 plus negative 3. Does that add to negative 2? 5 plus negative 3 is what?
2.
2. It's positive 2. 1 plus negative 15, what does that equal? What's 1 plus negative 15? Negative 14. That doesn't work. Negative 5 plus 3? Negative 2. These are our numbers. We win. Negative 5, and I'm going to write it as positive 3. And if you follow this method, it's a trick to go backwards and to figure out what your original binomials were.
Is that even on?
No. Sam?
What if you have one that's a negative and a positive?
Good question. Let's go through these examples, and there should be one of all positive negative combinations. Actually, in all your homework problems, you can start them out by writing parentheses with x's in the front. And so the first example, x squared plus 5x plus 6. We need 2 numbers that add to 5 and multiply to 6. Some of you might be able to just look at it and realize, oh, I know those 2 numbers. Others of you may need to write out all the factors of 6 or all the possible numbers that could add to 5. Now, you can come up with a list of infinity numbers that add to 5. That will go on forever. However, there's a very limited list of things that can multiply to 6. So, if you need a strategy, I would find all the factors of 6.
2.
So,
3.
Give me some. 2 and 3.
6.
Any others? Ben?
Well, I have a question.
Go ahead.
So, we'll only be dealing with whole numbers, right?
Yeah. Nils? Uh-huh.
Are we ever gonna like you can't draw it?
Yeah. Luke?
-2 and -3.
-2 and -3. Thank you so much for saying that. In this case, when you add -2 and -3, that middle number would end up being a negative. And so right now, if you realize that this is going to be a positive number, you'll try to stick to all the positive factors. But to write out a list of all the factors, you cannot forget negatives. Is that it? Is that all the factors?
No.
Luke?
1 and 6.
1 and 6, and then -1, -6. All right, what adds to 5? Lars?
3 and 2.
3 and 2. Positive 3?
Yeah.
Positive 2.
Mr. Hofman,
Yeah.
we get this from the
Not yet. Let's go down to example letter C. Positive 3. What multiplies to positive 3? No, what multiplies to positive 3 and adds to -4? Lars, give me 2 numbers.
-1 and +4.
-1 times
+4.
4. -1 times 4 is going to multiply to -4.
Oh, no.
And so what you might want to try is -1 times -3. When you do -1 times -3, that multiplies to 3. Shh, ladies in the back and gentlemen. Now, -1 times -3 multiplies to 3. Does it add to -4?
Yes.
It does. You guys are all going on this. That's great. Let's do letter E. Positive 2. What 2 numbers multiply to -8 and add to +2? Ellen?
-2 times 4.
-2 times 4 will multiply to -8. Since the +4 is bigger than the -2, they will add to a +2. Now suppose that you chose this, +2 times -4. Yes, they'll still multiply to -8. But if you did that, your middle term would be at a -2 instead of a +2. Emily, how do you feel about it? Who would like me to go through more examples?
Can I go in all this?
Yes. All right. I need all of you guys. I'm going to walk around the room and check some answers. I need all you guys to work quietly for a little while while I check answers and talk. Yeah, really quiet.